Hello, this is Mrs. Fontanes. I have here a PowerPoint for you. Cycles, law of conservation of matter is what we're going to be talking about. Okay, by definition, if we're going to be talking about the law of conservation of mass, we got to know what is it? Well, we have to understand what matter is. By definition, matter is anything that has mass and takes up space. So, for instance, if we use a scale and we're measuring something in kilograms, that's going to tell us how much mass it has. So, matter will have mass. Let's look at these buildings. Look at this cloud, this hamburger, the window, the whale. All of these is a bacteria, books, a spoon. All right. So we have here rocks, we have a shirt, we have a leaf. By the way, we have some stuff that are alive. Remember Bill Nye the Science Guy talking about cells? Okay, here we got a leaf, that's alive, but not a rock, not a shirt. A whale is alive, the bacteria is alive, but not the books, not the planet Saturn or the clouds, but they are all made of matter. So, the law of conservation of mass. When we're talking about something that is conserved, we're talking about something that is not lost. Mass is neither created nor destroyed in any ordinary chemical and physical changes, like chemical reactions. So let's look at this reaction. Here we have a log, and we add some energy to it, fire. It turns to ashes and smoke. But if we were to analyze what's in these ashes and what is in the smoke, we will find it all came from the log. So it changed, but it didn't get lost. Okay? If we were to take a mass reading of the log and the mass reading of all of this, the ashes and the smoke, we're going to find that the start and the end amount of mass is going to be the same. So the law of conservation of mass means we're not going to lose anything. It's going to be preserved. It's going to be saved. What we start out is what we're going to end up with. Well, what does that do? What does that have to do with us? Well, photosynthesis. Remember these equations? Water reacts with carbon dioxide and light from the sun, to produce oxygen and glucose. That's the sugar. And then cellular respiration, we have oxygen reacts with glucose to produce water and carbon dioxide and energy. In this case, ATP, a high energy molecule, adenosine triphosphate. So, looking at these two reactions, we know that the reactants are on the left. That means this is what is reacting: water, carbon dioxide, and light. And this is what's reacting in cellular respiration: oxygen and glucose. The products are on the right. So the products was what's made, what is produced in photosynthesis is oxygen and glucose. And what is produced in cellular respiration is water, carbon dioxide, and adenosine triphosphate, or ATP, that high energy molecules. Okay, so this is nothing new to you. So when we're comparing these equations, photosynthesis and cellular respiration, we know the reactants are on the left, the products on the right. Oh, wait a minute, what's happening here? Well, now this is a reactant, this very same thing, oxygen and glucose. Okay, they are the reactants in cellular respiration. And we see that over here, whoops, water and carbon dioxide and ATP are the products of cellular respiration. It used to be a reactant. So these two types of reactants are opposites of each other, but there's actually more to this than what we see here. All right, so you've seen this before too, the overall relationship between photosynthesis and cellular respiration. We're going to start here. By the way, we have photosynthesis on this side. Photosynthesis occurs in the chloroplast of the cell. Respiration is on this side. It occurs in the mitochondria of the cell. Photosynthesis and cellular respiration occurs over and over again. We're going to see that nothing is created or destroyed. All compounds are recycled. The law of conservation of mass is going to be preserved. This obeys the law of conservation of mass. Let's look at this. We're going to start here. Here we have 6 molecules of water reacts with 6 molecules of carbon dioxide. These are the reactants of photosynthesis. Here we go. We see the sun here providing the energy for this reaction, and we get this product. This is the glucose, sugar, and 6 molecules of carbon dioxide. Sorry about that, the little number 2 didn't show up here. All right, and then what happens? Wait a minute, now this turns into a reactant? Yes, it does. It turns into the reactant for respiration, and this becomes the products of cellular respiration. So let's look at that again. All right, so we're going to start here. 6 water molecules and 6 carbon dioxide molecules, they're the reactants of photosynthesis, and here we have the sun supplying the energy. And this gives us the products, the glucose plus 6 oxygen molecules. Oh, wait a minute, it turns into reactants for cellular respiration, which produces 6 water molecules and 6 carbon dioxide molecules. Nothing was lost. Mass was conserved. It follows the law of conservation of mass. Everything is recycled, and this happens over and over again. Okay, so the law of conservation of mass. Mass is neither created nor destroyed in ordinary chemical and physical changes. We must start and end with the same amounts, and we saw that over here. We started with 6 water molecules and 6 carbon dioxide molecules. We went all the way around, and we came back to 6 water molecules and 6 carbon dioxide molecules. When we got this product, 1 glucose molecule and 6 oxygen molecules, these were the products, and these were the exact same thing for the reactants of cellular respiration. So nothing was created or destroyed, just like we saw in here. Matter is neither created nor destroyed. Well, why are we studying this? And why in this manner? Remember, we talked about photosynthesis and cellular respiration. We talked about reactants and products. We talked about how photosynthesis and cellular respiration occurs over and over again. We talked about how photosynthesis and cellular respiration obey the law of conservation of mass. Well, now we're going to take this a step further. The biogeochemical cycles. We're going to talk specifically about carbon dioxide, or rather, carbon and nitrogen. And again, this happens over and over again. Nothing is created nor destroyed. So let's look at this word. Etymology. Etymology means the Latin and Greek word roots. Remember, we've talked about that before. And in my classroom, I have a little chart with those word roots. Well, chem comes from the Arabic word, and here we go. I don't know Arabic, but here we go. Kimia. All right. Also known as alchemia. But that's where chem comes from, for chemistry. But what does bio mean? What does geo mean? Okay. We have an assignment. This PowerPoint is found in Google Classroom within the Classwork tab. Also, in the Classwork tab is the Google Doc labeled, and I forgot to put the number here, but it's conservation of mass, okay? This is today's assignment. Answer all questions. You can use this PowerPoint and the internet, and make sure you press submit when you're done. I'll be seeing you later. Bye.